Okay, we're just going to quickly go through the examples, just so that you have an idea of how to do the work. So if we look at the first one, it's an example of a velocity. So determine the length of a student's arm if she can swing a pail around 5 times in a circle. So period of rotation is, again, how many times per it takes to do a revolution. So we're basically doing 5 in 7.5 seconds is basically equal to 1 in blank. It's kind of basically just a cross multiplication, right? So if you basically take 1 multiplied by 7.5 divided by 5, we're going to get this number here of 1.5 seconds is equal to t. Now from there, we can substitute that into the equation, right, with our values. So we have t, 1.5 seconds. We have velocity, 2.72 meters per second squared. And that's it. V is equal to 2 pi r over t. Got a velocity, got a period of rotation, have pi and 2, solve for r. So manipulating, I get large T V is equal to 2 pi r, divide both sides by 2 pi. Sounds like a meal, TV over 2 pi's. Is your radius. That's our equation. We can see here, period of rotation multiplied by velocity, divided by 2, divided by pi, and then we get a value for r of 0.65 meters. And that's it. Next, if we look at example 2, we're looking at a centrifugal acceleration question. So in this particular case, we have something going at 60 kilometers per hour. We have the length of the traffic circle, right? So that we look at this, we got a couple things we need to do. Number one, that's not a radius, it's a distance across, right? So d is 2r, so r is equal to 60 meters. The next one we have is, of course, 60 kilometers per hour. We need to get that in meters per second because our units there are meters. So we can basically multiply that by 1,000 meters in a kilometer, and 1 hour is 3,600 seconds. So 60 multiplied by 1,000 divided by 3,600 will give us hopefully 16.6. Trusting it does, should be right. Once we've got those, we can plug it all into the equation. So we have V, 16.6 meters per second, R, 60.0 meters. Substitute in, right? We get 16.6 squared divided by 60, and mathematically that works out to 4.6 meters per second squared. Right? Now, all right, we're going to go over example 3 here. Now, one of the key things when you're doing questions is ask yourself this: do they give you velocity? If velocity is present, really you've got one of 2 equations, right? You're going to do A is equal to V squared over R, or basically something with V in it, right? V is equal to 2 pi r over t or something, right? Both of those equations have V in it. If you don't have V, you're going to be using one of the other equations. In this particular case, we look at our variables. We have the horse in this track, we have the radius, and the time it takes to run the radius. So basically, if they tell you they do 1 lap every 12 seconds, they're basically saying t is equal to 12 seconds, r is equal to 37 meters, right? No V, so you have to use an equation without V in it. In this particular case, A is equal to 4 pi squared r over t squared. And all you have to do is, again, substitute your values in. Your period of rotation, 12 seconds. Radius, 37 meters. And then at that point there, it's just simply the math. Do watch your order of operations, like watch, so that when you're squaring just the values that you're wanting to square, not like 4 times 3.14 and then square all of that. If you do that, you should get 10 meters per second squared. And those are our first 3 examples that deal with kind of velocity and centripetal acceleration. The next ones have to do with centripetal force. In example 4, we have kind of one of those instruments that goes round and round, spins the astronauts around. We have the information here provided, so it's basically saying, normally you feel 1 gravity force, which is 9.81 meters per second squared, so times that by mass, it's 9.81 times 10 to the second newtons for a 100 kilogram person. Now in this particular case, this 100 kilogram person is spun in an 8.8 meter radius circle at a velocity of 10 meters per second. So what's the centripetal force? F is equal to mv squared over r. So we have our mass of 100 kilograms. We have our radius of 8.08 meters. And we have our velocity of 10 meters squared. So 100 multiplied by our 10 squared, right, which is going to be 100, divided by 8.80. So we do that, we get 1.14 times 10 to the third newtons. Now in this particular case, they ask you how many G's you feel. In order to figure that out, you basically take your force experienced and then divide that by the force of gravity. So in this particular case, the force experienced is the centripetal force. So Fc, we divide that by the force of gravity. So if we're experiencing twice the force of gravity, it would be 2 G's is what it would work out to. In this particular case, you divide those two numbers, you get 1.16 G's. So slightly more than gravity. Now in the second example, down below, we say what happens if we increase our speed from 10 meters per second to 15 meters per second. So we're increasing the velocity by 50%. We do the math, same thing, the difference is now it's 115 squared over that 8.80 meters. The difference here is now we get a centripetal force of 2.56, which is really double that. So we go from 1.16 G's to over 2 G's now, which is pretty significant for only a 50% increase. Where is that? A 50% increase in velocity. Now, this last example that I'm going to go over today is a good one because it uses kind of a different set of vocabularies. Instead of giving you like period of rotation, it's actually RPMs, right? So they're saying here that it's the 100 kilogram man in the 8.80 meter per second or meter radius centrifuge, but they're spinning at 15 revolutions per minute. So basically, 1, 2, 3, 15 times in a minute. So you can do it a couple ways, but I mean, it's really 15 times in 1 minute. If we do this. All right, the last example I'm going to go over today is example 5, and it's a good one because it uses a little bit different vocabulary. Instead of using like the revolutions or period of rotation, it's using RPMs. So here we have spinning at 15 RPMs. Now, if you remember from lesson 31, we talked that really RPMs or revolutions per minute is pretty close to frequency, which is the times per second. All right? So basically, if we take our 15 RPMs, divide by 60, we get 0.25 hertz. And that is the key thing again, is its frequency. If you remember, again, T is equal to 1 over F, or basically frequency is 1 over T. They're the inverse of each other. So what that means is if you take your frequency, which is 0.25 hertz, divide that by 1, you should get your T or your period of rotation. So we do that here, and we see that we get 4 seconds. So in short, if you're given RPMs, divided by 60, divide that by 1, and that will give you your period of rotation. And that's something that you can use in your equations, right? Once we have that, take a quick look. Do you have velocity anywhere? Nope, I don't see V any there. You got mass, you got radius, you got RPMs, no velocity. So you'll notice that the equation that we use doesn't have velocity in it. It's just the easiest way to go about it. At this point here, we substitute the values in. M we know, 100 kilograms, that goes there. Radius we know, right there. Period of rotation, we've solved for that over here by simply taking 1 and dividing it by RPMs divided by 60. At that point there, we simply do the math, and you should get 2.2 times 10 to the third newtons, like 2,200 newtons of force. That's it. So hopefully we quickly went over the examples here, gave you an idea of how to do some of the questions. Obviously there's lots of different styles of questions. The easiest way to get experience doing those questions is to try a bunch of different ones. So have at her, and we'll come back for lesson 33.